Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will start talking about a new topic, which is the electrical circuits. So fasten your belt and let's get started. The aim of this tutorial is to know what are the different types of the electrical circuits. So we need to know what are the different kinds of circuits which we can handle during our circuits design. Also, we will learn how to design the circuit system. So we need to know how can we make a full design for the electrical circuits by learning those different designing steps. So let's go ahead. First of all, we can categorize the electrical circuits according to the power phase. So we specify the type of the circuit according to the power range which it can withstand. And according to this phase, we can have two main categories of the electrical circuits. The first one is the normal circuit, which has the lower power range or the normal power range, and the second one is the power circuit, which has the larger power range, or we use if the load consumes a larger power rate. And we use this normal circuit in case of the load which will be connected to the circuit consumes a power which is less than 1000 volt ampere. So if the device or the electrical appliance which will be connected to the circuit has a power range that is less than 1000 volt ampere, we use this normal circuit at that case. And this normal circuit is only of the single phase type. So if we found any normal circuit, it must be a single phase circuit. Like this shape here, you can see this is a normal circuit. And you can see also it has three holes or three plugs. One for the line wire, and one for the neutral wire, and the third one for the earthing wire. And also this is the shape of the normal circuit, where those two holes are for the line and neutral. And those two pins here are for the earthing wires. So that's for the normal circuit. Now for the power circuit, it's used if the power of the device which will be connected is larger than 1000 volt ampere. So in case of a larger load, we need a circuit which can withstand the larger power and the larger current ranges. Hence, we use the power circuit at that case. And this power circuit can be a single phase circuit or a three-phase circuit. And this is unlike the normal circuit, which is only a single phase circuit. And here this is the shape of the single phase power circuit. It has three terminals also, one for the line, one for the neutral, and a third one is the earthing wire. And you can see the earthing terminal is larger than the line terminal in its cross-sectional area. And this is to have a lower resistance by having the larger cross-sectional area. So when the resistance of the earthing wire is lower, this helps in absorbing any leakage current, so the earthing system will be working well. And also we have the three-phase circuit, and this is its shape. And at that case it has five terminals, three for the three phases R, S, and T, and one for the neutral. And the fifth one is the earthing wire. Very good. So that's for categorizing the circuits we have according to its power range to be a normal circuit or a power circuit. Now we have another categorizing process for the circuits based on the circuit itself, not on the power of the circuit. So we are not categorizing now according to the power, but we are categorizing according to the type of the circuit itself, or according to the usage of the circuit. And here the first type is the single circuit, and at that case we have just one circuit, and in that case we have only one electrical load, so we use one circuit to feed this load. So if the frame includes only one circuit, it will be a single circuit. Also, the second type we have is the double circuit, and at that case the frame of the circuit has two circuits included in the same frame. And we use this double circuit in case of we have two loads and we need to feed each of them. So each circuit will feed one load. Also, the third type of circuits we have is the weatherproof circuit. And this type of circuits is an ordinary single circuit, but it has the feature that it's a weatherproof one. And this means this socket against the weather condition like the rains or the dust, and this is because it has a cover like that one, or it has a well-designed cover which disable the water or the dust to reach the socket terminal. And for that purpose, we find the weatherproof socket to have a larger IP number as it prevents the water and dust. Alright, now the fourth type we have of the socket is the UPS socket. And this UPS socket is an ordinary socket, but it's used for the UPS application. And the UPS applications are the applications at which we have two different sources which are feeding the electrical load in parallel. And those two different sources are the main source or the ordinary source, which is the electrical utility, and the second one is the UPS, which is the abbreviation of the uninterruptible power supply. So there is another power supply which will feed the load in case of there is a failure in the utility system. So the UPS works as a backup system to work as a second source for feeding the sensitive loads. Hence, if we have some UPS sockets, this means they are connected with two different sources, the utility and the uninterruptible power supply, which will feed the load connected to the socket in case of shutting down the utility or in case of the failure of the utility. Very good. Now the final type of sockets we have is the switched socket, and in that case we have a switch connected to the socket to control it. So if the switch is on, the socket will conduct the electricity to the electric load, and if the switch is off, the socket will not conduct the electricity to the electric load. So we can say that the switched socket looks like the single socket exactly, except that it has a controlling switch to turn the socket on or off. Alright, now the important question is that how can we specify the power of the socket, or how can we select the suitable socket required for a specific type of loads? Here we say that this depends on the power of the load that will be connected to the socket. So suppose we need a socket to be connected to a refrigerator. Here the refrigerator maximum power is about 500 watt, but this 500 watt is less than 1000 watt. So we will use a normal socket to feed this refrigerator. As we said, if the power is less than 1000 watt, at that case we use a normal socket. Also, the second popular device we have is the computer, and the computer has a maximum power range of about 200 watt, which is also less than 1000 watt, hence we use the normal socket to feed the computer. So the normal socket is used also in case of the electrical load as a computer device. Now the third device we have is the vacuum cleaner, and the vacuum cleaner consumes a power of about 2000 watts, so it's larger than 1000 watt, hence we use a power socket at that condition to feed the vacuum cleaner. Also, the same idea is applied to the electrical water heater, as it consumes a rated power of about 1500 watt, which is larger than 1000 watt, hence the power socket is used in case of the device we are using as a vacuum cleaner. And the same thing also for the washing machine, as the washing machine consumes a power of about 1200 watt, which is also larger than 1000 watt, hence the power socket is used in case of the load we are connected to the socket as a washing machine. And also the fifth device which we face frequently in the socket design is the microwave, and it consumes a rated power of about 1000 volt ampere. And in that case, it's recommended to use a power socket to feed this microwave. So that's for the different electrical loads and the sockets which are suitable to feed them. More than great. So that's about this tutorial at which we learned about the different types of sockets we have in the distribution system. Hope that's clear right now. Thank you for watching and see you in next tutorials.